So continuing where we previously left off, the I told you that an equation like this, whether it's quadratic, cubic, or quartic, it always becomes according to Newton's sums. It becomes 9s3 plus 2s2 plus s minus s1. My bad, s1 and then s0, which is equal to 0. So I told you that S0 is just the same as the degree of the equation, which would be 3 in this case. So S0 is equal to 3. Let's just write that down. So S0 is equal to 3. But why is that the case? There is two ways to visualize this. Let's do both of them. Let's do the short one first and then the long one. So as you all know, S1, or let's just write Sn equals to sum of the nth power of roots. That means alpha power n plus beta power n plus gamma power n. So this would mean S0 equals to alpha 0 plus beta 0 plus gamma 0, which just becomes 1 plus 1 plus 1, which is equal to 3. And this works the same with the quadratic and the quartic equations as well. In quartic, there would be four roots, so that would be 1 plus 1 plus 1 plus 1, and that would become 4. So the bigger way, the longer way, the larger way, would be uh, a proof to also explain why this is the case. Why does this happen? So let me show you why that happens. Let's bring the original equation down here. So we can write this as you already know in polynomials, when you use a root of a polynomial, the equation still remains valid. What I mean is, if I write it as 9, this looks like okay, 9 alpha cubed plus 2 alpha squared plus alpha minus 1 equals to 0. This still remains valid. This is a valid equation. And if I write it as 9 beta cubed plus 2 beta squared plus beta minus 1, this would be equals to 0 as well. And the last one, second, okay, 9 gamma cubed plus 2 gamma squared plus gamma minus 1 equals to 0. So this is the three equations that are possible with this because there were three roots, alpha, beta, and gamma, and if we plug them into the original equation, they would still make sense in this. You can try doing this by actually calculating a polynomial and then substituting the roots. The answers you get inside the original equation, you will get 0 every time. So continuing with this, I'm going to show you how we get the S form of the equation where we use S3, S2, and S1, 0. So let's do something here. Let me just put a line and scroll down a bit so you can see. Okay, that is perfect. Now, if you see, if we add all the equations together, that would just give us 9 alpha cubed plus 9 beta cubed plus 9 gamma cubed, then plus 2 alpha squared plus 2 beta squared. I could just factorize it and write it quickly, but I want to explain it, so I'm going to write it the long way. Plus 2 gamma squared, and then I'm going to go to the next line. So I save space plus um, alpha plus beta plus gamma, and then adding all the ones, which would just be -1, and -1. Because plus minus is still minus, so -1, and -1, that would be equal to 0. This all becomes equal to 0 because 0 plus 0 plus 0 is still 0. We just add from top to bottom each term. So taking the common of each of the terms, in the first three terms we can have 9 common. So we can take it as, like that. We can have that as 9 and then bracket alpha cube plus beta cube plus gamma cube. Then we can have plus, then we can take 2 common. So that would be alpha squared plus beta squared plus gamma squared. And then I'm going to the next line, just to save space. That is the same as alpha plus beta plus gamma. Okay, and then the last one is just -3. Because -1 just makes -3. And this all becomes equal to 0. So now you see the term after the whole bracket after the 9 is alpha cube plus beta cube plus gamma cube. And what do we remember that makes? That is S3. So we can write that as 9S3. Let me just scroll down a bit. Okay, 9s3, and then there is plus 2. The bracket has alpha squared, beta squared, and gamma squared. The squares, the sum of square of roots, that is s2, because the power is s2 on each of them, so that is going to be s2. Then same with the other one, s1. And then now, this is an interesting one, s0. S0 is going to be a 3 because it's going to be minus s0. Minus is already there, so s0 is just 3, which would be equal to 0. So this is the same form we made up here, the one we just wrote here. Let me just mark that. This one. This is the same as the one we just made here. And of course, you can modify it however you want. This can also become, this should be not equal to, this does not mean equal to, but it can also be 9s4 plus 2s cubed plus s squared minus s1, which would equal to 0. So it's the same thing. And we can also uh, make it go one number down or two numbers down or any amount of numbers you want to make it go down. So instead of 9s3, this can be 9s0 for the first one. Let me just scroll down. And then it can be 2s minus 1 and then s minus 2 and then minus s minus 3, which is equal to 0. This is still valid. So this is the proof for the Newton sum and how we can modify it for our convenience.